Section 3.4 deals with the graphs of these, and some things that we've come across but haven't officially learned is that if I have a polynomial, which is what we're dealing with in this section, and the degree is odd, meaning the leading power, the highest power, is an odd number, like a 7 or a 5 or something like that, the graph is going to go in opposite directions. On the left and on the right, it's going to be in opposite directions. One's going to be low, one's going to be high. And I can further decide what it is based off of if the leading coefficient, which is in front of the, is positive or negative. If it's positive, like let's say it's a 4, the graph will in general go uphill from left to right. So you're going to have something like this. Maybe it has some wiggle in the middle, but in general, notice that it's going from the bottom left to the top right. And vice versa, if it's a negative out in front and it's an odd power, it's going to go from top left. Again, it might do some stuff in the middle, but it'll go from top left to bottom right. If the if the degree is even, so like if I have x to the 6th or 4th or 8th or 10th or whatever, then the graph is going to go in the same direction. If it's positive out in front, so like let's say it was, I don't know, a 7 out in front, the graph is going to start up high. It might do some wiggle, but it's going to end up high. So notice it's going in the same direction, up and up on both ends. If that number out in front is negative, then it's going to start down low, do some stuff, and end down low. And again, the amount of wiggle and stuff, that all depends on zeros and how much is going on. But this gives us a general feel for what the graph's going to look like. So for these first 5, we're going to match to these graphs, which, let me see if I can get this zoomed out enough to where we can actually see all of them. So first one, 3x to the 6th. So we're going to look at two things. The power's even. That tells me the graph is going in the same direction. So either it's C, because that's going in the same direction, D, that's going in the same direction, or E. It has to be one of those. The number out in front is positive. That means it's going to basically start up high and end up high. So this has to match E. And then it also wants the intervals of increasing and decreasing. This is stuff we've done previously. This graph is going downhill over the x numbers. Remember, it's always the x intervals from negative infinity until it reaches 0. So it was downhill from negative infinity to 0. The graph then is going uphill. I'm sorry, I had that backwards. Sorry about that. It's decreasing first. So decreasing from negative infinity to 0. There we go. It's increasing from 0 to infinity. For number 2, it's an x to the 7th. Okay, so that tells me opposite directions. So I'm looking at either A, B, or F, because those are all going in opposite directions. It's positive out in front, so that means it's going from bottom left to top right. Think of it going uphill. The only one that's going uphill from left to right is A. And this one never drops. You're always walking uphill. So this will be increasing from negative infinity to infinity. It's never decreasing. For number 3, again, I'm first going to look at the power. The power is odd, x to the 5th. So that tells me opposite directions. So again, I'm looking at A, B, and F. It's negative out in front, so this means it's going to go downhill from left to right. Well, both of these go downhill from left to right. Notice the only difference is that graph B is shifted up a little bit. That's this +1. Remember from last chapter, that's a shift up 1. So this has to be letter B. This one, letter B, is always falling. So it's never increasing, it's decreasing from negative infinity to infinity. For the next one, even power, same direction. So again, we're looking at C, D, or E. Negative, so it's got to be downhill both ways. So, and I didn't draw these on the other ones. I probably should have. This one was going something like that. Number 3 was going downhill. For number 4, it's going to be down to the left and right. Again, both C and D have that, but notice where they have their peak. X minus 2 means go to the right 2. So this has to be letter C. And then this one is increasing. I'm going uphill from negative infinity until I reach the number 2. That's a number 2 on there. I'm then going downhill from 2, oh my, to infinity. That is gross. There we go. And for the last one, odd power, so opposite directions. So again, we're looking at A, B, or F. Negative, so this is basically the same scenario as we had for number 3. That means it's going to be going up to the left and down to the right. This one, though, doesn't have that +1 on it, so this has to be letter F. It's not shifted. And again, this one is never increasing, it's always decreasing. So now we're going to use that knowledge along with stuff we've done previously to graph these polynomials. Again, let's use the knowledge that we just attained. Even power means same direction. Negative out in front, that tells me this thing is going to go low on the left and low on the right. Well, think back to last chapter. Oh, this is a parabola. Yeah, parabolas go in the same direction, and since it's negative, it would be reflected. Yeah, this makes sense. If you remember, this means go to the left 4, if I use my transformation rules, down 3. So left 4 and down 3 is going to be the vertex of this parabola. And then since it's got a vertical compression or vertical shrink on it, it's going to be smushed a little bit more than the normal one. You could make yourself an XY table. Online, you only need 2 points for it. Let's say you plugged in -2 for X. If you plug -2 into the function, you'll get, let's see, -5 out. So down, or sorry, back 2, down 5. And since it's a parabola, we know it's got a symmetry over here. But again, what I'm wanting you to focus on is the fact that that's an even power, and this was negative. Same direction, down, down. For letter B, odd power, to the third, so that means opposite direction, and it's positive out in front. That tells me this thing's going to be going from low to high. It's going to be going uphill in general. And if we think about it, oh yeah, it's a cubic. Cubics look something like that. This would be to the right 2, and this would be up 3. So right 2, up 3. There's no stretch or compress, and if you remember on the cubic, you'll have a point diagonal down and left, diagonal up and right. Now on line, it's going to need 4 points. Another point you could get on this would be the y-intercept. So I would get the y-intercept by plugging in 0 for x. So if I plug in 0 for x, that's going to give me -2 cubed plus 3. So that's -8 plus 3. So your y-intercept is 0, -5. So that would be a good 4th point on that. And I can see that this thing goes down to the left, up to the right, which is what it was supposed to do.